So let's start, ma'am. Okay. Good afternoon. It's a day 2, session 3, last session, afternoon session. So I welcome Dr. Abha Jain, ma'am, Associate Professor at Prestige Institute of Engineering and Management and Research in Indore. She has 15 plus years of teaching and research experience. Her research interest is including mobile communication, machine learning, and Internet of Things. So today, as we have the two sessions, morning session from Dr. Rajkamal sir, and Abha Jain madam is proceed with that some experimental or some demo kind of project or the presentation for IoT systems. So I welcome Dr. Abha Jain madam, and over to you.
Thank you, sir. Am I audible?
Yes, ma'am. Yes.
Thank you very much for your kind words. And I'm going to present my screen first of all. Good afternoon. I am Dr. Abha Jain from Prestige Institute of Engineering, Management and Research. Once again, welcome in Untitled FDP Day 2 post-lunch session. In this session, we are going to cover Raspberry Pi introduction, OS installation, and then I will demonstrate interfacing of sensor actuator with RPI. Data we are receiving from sensor we will send to ThingSpeak cloud. Also, we display receive data in display screen. And finally, we interface a camera module with RPI. So this is the roadmap of our journey for today. And I hope you are able to see my screen.
Yes, ma'am. Now your presentation is visible, yes.
Yeah, let's begin with RPI. This is a smallest computer which can be keep in your palm. You can compare this with your credit card size. It's a single board computer, but with all these, you're not going to compromise with the speed as we are having CPU and GPU facility on this single board computer. The feature of this RPI is most attractive feature of this RPI is it's a low cost and small size. The pattern of working of RPI is same as it fetch the program from RAM and flash memory, which load the program and data from flash drive execute the instruction and finally send to our input-output peripheral. This is the board we are having with us. So let's have a look. Are you able to see my video?
Yes, ma'am.
Yes, ma'am. Yes, yes.
Okay, let us have a brief overview of our board. There are different model of RPI, that is a Raspberry Pi, based on speed, memory, size, weight of the board, cost, etc. And some of the popular boards are RPI 0, RPI 2, RPI 3, and the latest version RPI 4. We are having here RPI 4 with 8 GB memory. This is the latest version of RPI 4. Right here, we are having Ethernet port for internet connectivity, and along with this, there are two USB ports, that is USB 3 for fast data rate transfer up to 5 GB per second, and USB 2 with maximum speed of 480 megabit per second. This is 3.5 mm audio jack. This port is. This is audio jack. And 2 HDMI connectors with which you can connect 2 monitor or 2 display with RPI. In between this HDMI and audio jack, we are having a cylindrical connector for connecting camera, which must be RPI compatible camera. And here we are having a USB type C power connector just to power up RPI board. Then across the top, we are having a 40-pin GPIO connector. GPIO, that is general purpose input-output pins. Any of the GPIO pin can be designated via software as an input or output pin and used for a wide range of purpose. Note here the numbering of GPIO pin in numerical order. For example, GPIO pin 0 and 1 are presented in board physically pins 27 and 28. 2 5-volt and 2 3.3-volt power pins are available along with some ground pins. Easy way to find out GPIO versus physical pin, just type pin out on terminal, and on your screen you will see GPIO versus physical pin display. Right here we are having 15-pin DSI display collector also. Now if you flip this over the bottom, here we are having micro SD card slot. For operating system of RPI, we need to install our operating system in a micro SD card, and this is the slot for this micro SD card. Flip back and look at some components we left with. At the corner, we are having Wi-Fi and Bluetooth module. This is CPU and this is RAM. Next to GPIO, we are having a 4-pin PoE header just to power up our RPI through Ethernet rather than our
now my PPT is visible to all of you.
No. No, madam.
You have to share again.
Just a minute. Now, this is visible?
Yes, yes.
Okay, so as we have seen in our RPI, we are having a slot for micro SD card. We need to install our OS in that micro SD card. So in order to install our operating system in micro SD card, we need some external component, and this is HDMI cable, then keyboard as the input, and a display to see our output. This is RJ45 LAN cable just to connect our RPI with Ethernet. Although I am showing you that RPI 4, which is Wi-Fi compatible, and of course micro SD card, and with the power adapter of 5 volt. So let's start how we can install our OS in our micro SD card. So let us take a computer in which we are having the facility of micro SD card reader writer port. Put your SD card in the reader and select the drive. please be careful as we are going to format our SD card. So if you choose wrong drive, then you may lose your all the data you are having in that drive. So be careful at this point, and then format our SD card choosing fade file system using the command at the computer. Now your SD card is ready. The second part of this installation is to download latest Raspbian operating system. So go to this URL here. Actually, you will get the recording of this lecture. So I have put each and everything in this PPT. You can, if you want to install, then you can have every information. So go to this site and download Noob's OS installer. Rather than downloading directly Raspbian OS, we are going to install this OS via Noob's OS installer. Noob's OS installer gives us the flexibility to install more than one OS in the same micro SD card. So this type of screen appears in your system, and in which you are having the information of version, release date, size. If you want to choose particular one, then you can observe over here and then click on this download zip. Now you are having a zip file. Extract this zip file and copy all the files. Copied file you can paste directly on SD card. And now your SD card is ready to remove from your SD card reader and insert into the SD card slot of RPI. We have seen our video. Now connect a monitor terminal with RPI with HDMI port. I have shown you HDMI port. You can connect any monitor. It may be your TV screen or your display available with your computer or any type of terminal. And then you need to instruct our RPI with the help of keyboard. So a keyboard which is USB port equipped and a mouse. For powering up our RPI, we need an adapter. And with this, you can give power to your RPI. As you first powering up your RPI, you are greeted with this screen. Here we are having two options, that is Raspberry Pi OS or LibreOffice. If you want to select both of them, then you need this much of space, that is 7000 MB. And if you want to install only first one, then also this is okay, because in the second file, only some games are available. So if you want to do only programming or the computational operation with your RPI, then first file is sufficient. So just click it and now have some patience, because it will take some time. So wait for a minute, rather few minutes, and then you come across with this information, that is to install successfully. Now you have installed your RPI OS successfully, but when you first time boot up, then you need to set up some other requirement. So just choose the next button over here. This is the instruction, which is when first time boot your system, you will see. And when you press this next button, then you come across with some formalities and just choose according to the instruction. For example, choose your country name, choose your native, whatever language you want to be, time zone, etc. This is the first time setting only. So be careful when you choose all the information. Then Raspberry Pi also offer you to change your password. So if you want to put password, then write over here and confirm your password. And this is what we were talking about, that is in RPI 2 and RPI 0, there were no facility of wireless. But in RPI 3 and 4, wireless and Bluetooth facility is available. So you can configure your wireless setup over here. This is the window. When you choose this window and enter the wireless facility available in your premises, and then select that one to connect your RPI with wireless network. And finally, you come up at this stage when RPI asks you to update software. You can choose here that you update your all the software, or you can update your software via terminal. There are two choices, but I suggest once just choose this and update all of the software available in operating system. And then this screen appears on your display. Finally, you are with the RPI OS, and this is these are the icons available on the top panel of your display. The first one is for menu. When you click this icon, then a menu pop up. This is for browser, just to, as we have seen that we can connect our RPI with wireless network. So with the help of this browser, you can do anything, whatever you want to do. In fact, this is your small computer. So you can search, you can anything, you can run your YouTube, etc., etc. And this is the file system. And finally, this is your terminal for command line operation. In the menu, when you pop up this menu, this window pop up, programming, then education, and so on. And in the programming part, you can see over here that we are having a by default Python ID. I hope this is visible to all of you. This is Tholi Python ID. In the previous version of Raspbian OS, they by default provide you Python 2 and Python 3 ID. But right now, they withdraw this facility. So I manually install this Python 3 in my OS, in my Raspbian OS. You can also install Python 3 idle, Python 2 idle, or whatever you want to be. With the help of this sudo apt-get install idle. So this is, if you require, then this is possible that you can install other facilities with the help of terminal or with the browser. And this is what we need to configure first time. Command is sudo raspi configure. You can choose this command over here, or in fact, when preferences is also there, when you select this icon. Yeah, this is there. This are you able to see my cursor? This is preferences. When you click this preferences, then also this window pop up. Otherwise, you can write a command in your terminal, that is sudo raspi configure. Then this window comes on your display board, and with this you can change your password, you can change your network option, boot option, and etc. But we are more interested in one of the option, that is interfacing option, because we need to interface different kind of components with our RPI. So when I select this interface, fifth number of option, then this window pop up, and through this window I can enable my camera, because by default in Raspberry Pi OS camera is disabled. This is SSH VNC if you want to operate your RPI remotely. This facility normally used with RPI because we don't have keyboard and mouse, keyboard and display facility in the single board. Then what we can do, we choose this facility, and from my laptop I can operate my RPI from anywhere. So I need to enable all these facility when I first time come across these points. And this is I2C. We are going to interface our OLED display. So we need to enable this also. Later on we'll see this facility as well. And finally, this is what we can do, this is the terminal of our RPI. We can do update and upgrade for all the package we are having in our operating system. So this is a overview of installing our OS in RPI. I hope this is quite clear. So anybody can now install OS and RPI first time. Now come to the second part. Now we are ready to do programming or interfacing our RPI with different boards. So all is set now. So we'll start our second part of programming. We are going to interface these number of boards with our RPI. Anything? This is visible to all of you. Vaibhav, sir?
Yes, ma'am. Yes, ma'am.
Okay, that was by mistake. Okay, I thought somebody wants to ask something. If anybody...
yes, anyone have any questions? I also heard some noise from this.
Yeah.
Okay.
No problem. Okay, fine. So these are the boards we want to interface with our RPI. We just want to demonstrate interfacing of sensor with our RPI, and we chose DST11, temperature and humidity sensor, to interface with RPI. Then we just want to interface an actuator. So it may be a temperature dependent auto cooling system. In this system, we just fetch the temperature from DHT sensor, and according to the temperature, we can turn on or turn off a fan. But unfortunately, I don't have any fan with me. So I turn on and turn off a bulb in place of fan. So you can do the same thing with the fan also. And when we read our temperature from this sensor, we can send this information to a cloud. We chose ThingSpeak for this purpose. We send the temperature and humidity on ThingSpeak continuously, and we can display this information of temperature and humidity on a display screen, and we are taking for this purpose OLED. OLED display our temperature and humidity continuously, and finally we interface a camera with our RPI. So let's start with DHT11. These are the facility, as I have already informed you, with our RPI system. Interfacing DHT11 sensor, and DHT11 sensor is a temperature and humidity sensor. It can be used for weather study, home automation, soil temperature, moisture measuring, etc. It maintains accuracy due to each sensor is strictly calibrated in the laboratory. The range of this sensor for the humidity is 20 to 90%, and temperature value in degrees Celsius 0 to 50 degrees centigrade. I am talking about DHT11 because we are having two types of the sensor, DHT11 and DHT22, DHT22, and the range of both sensors are different. So I am talking about only DHT11. If you choose DHT22, that is DHT22, then the range may be changed. So these are the requirements for interfacing DHT11 with our RPI, DHT sensor, a 10 kilo ohm resistor, jumper wires, and RPI. How our DHT sensor looks like, this is here. It's a blue color chip, and we are having 4 pin in this chip, that is VCC, data. It's a non-used pin, so not connected, and finally the ground. When we put this DHT sensor in this way, that is these probe come in our side, that the order of pin is like this. So pin number 1, that is VCC, we connect to 3.3 volt supply. Data pin is the second pin, and the finally ground pin is we are going to connect with our RPI ground. So we choose some fixed pin here, connect pin number 1 to 3.3 volt. Pin number 2, that is DHT sensor data pin. We use pin number 11. As I have informed in the video, but that was not very clear, the GPIO pin and the physical pin of RPI are not synchronized. I mean, pin number 11 is GPIO pin number 17. So you need to know which pin you are using. If physically you count this is 11, then in the programming this information won't work. You need to know the corresponding GPIO pin. So you can type on your terminal pin out, and on your screen you will see the pin diagram, so you can find out corresponding pin. Pin number 4, we are connecting on ground. So let's start. These are the some software requirement. This is available in Adafruit DHT library. So we need to install this Adafruit DHT, and this is possible with Git. And I wrote here a command with which you can clone this complete library from GitHub. And now some other step to execute a program in Python. Just when you successfully download that library, go to the folder Adafruit Python DHT by this command and install a Python library using this command. This is the Python program, Python coding we are using to execute our interfacing. So first of all, you need to import this library rpi.gpio as GPIO, then import time just to provide the delay. And as you know, this is the Adafruit DHT which support this sensor activity. You know that some library already developed, and we want to use ready-made facility. We don't want to write a code in that much of detail. So what we can do, we just import that libraries where all these facilities are available. So this is what we are doing here. We import a Adafruit DHT library to support our sensor. Then this is GPIO set warning false, because sometimes what happens when we set our GPIO pin as the input or output or something else, then that value remain in that GPIO pin, and later on when we program, then it gives our false indication. So this is what we are doing. Then DHT sensor, we declare that we are using DHT 11. If we are using here DHT 22, then I must write here DHT 22. The pin GPIO is 17, as we have already discussed that physical pin is 11, but GPIO number is 17. So why I write here, it's a 17. And this is input pin, and in the RPI, if this is high, input pin read the information, and if this is high, then humidity and temperature we stored in the two variable humidity and temperature, and if instance is there, then the temperature and humidity we can print out, and if there is no value, then we print no value. And this is the slip time of 3 seconds. So let's have a look of this interfacing. I hope this is clear to we are going to interface DHT sensor with our RPI just to read temperature and humidity. This is DHT sensor. In DHT sensor, we are having two types, DHT 11 and DHT 22. So this is DHT 11, and we are having 4 pin in this sensor. The first pin is for VCC. Second pin is for data, third is not in use, and fourth pin for ground connection. So here my DHT sensor and my breadboard. Now the first pin is VCC, so I connect this pin with my RPI board VCC 3.3. So this is the first pin. Inside number 1 pin, I put this VCC to pin number 1 of my DHT sensor. Then I have inserted a register of 10K in between these 2 pins, and then this data pin I'm using GPIO pin number pin number 17. So as I informed you that the pin number, physical pin number and GPIO pin number, both are different, and this is pin number 17 means physically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 number pin. 11 number pin means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I inserted my data pin at 11 number, physically 11 number pin, and ground is third number pin physically. So I put this ground over here. This is the connection for DHT sensor. And now this is our program to read the value of temperature and humidity with the help of RPI. So first of all, as you can see, we import the Adafruit DHT. This is the library. We already installed this library, and we connected our sensor data pin at GPIO 17 number pin. So I wrote there GPIO 17, and this is as input pin. So we read this pin, and if humidity and temperature are giving some value, it will print this value, and this is the temperature and humidity. You can see over here, temperature is 29, humidity is 635. So this is how we can use DHT sensor with our RPI. Okay, so once again, come to our slide. My slide is visible once again.
Yes, ma'am.
Okay. Now, this is the second part of our interfacing. That is, as I have informed you that I don't have the fan. So maybe not, it's a temperature dependent auto cooling system. It's a temperature dependent auto lighting system. So I'm using a relay. This is the relay. It's a mechanical electromechanical switch. 3 output terminal. First one is for normal open, common, and normal close. These are the 3 terminals. And here we are having the 4 pins. First pin is for ground, last pin is for VCC, and this here we are having the 4 pins for individual relay, individual switches. So I have used this relay to interface with my RPI and connect with RPI. VCC once again to the 5-volt supply, ground is the ground of RPI, and input pin I'm using only the single relay, single switch. So input pin, I chose pin number 13, physically, pin number 13. So let's have the program. It's we insert these command in our previous program in order to operate our actuator, that is bulb, in with reference to our temperature. What we are doing, we just want to bulb turn on and turn off when we reach up to a threshold temperature. So here, this is the pin number, GPIO pin number I choose, and this is the threshold temperature. If temperature is more than 33, then my relay is active, and with the relay, I connect a bulb which turn on and turn off based on this temperature. So these code you need to insert in the main Python code, right? So let us see. Here we interface a relay in the same diagram we used for DHT sensor. We now trip the relay when the temperature is more than 33, and we connect a bulb with this relay as an actuator. Whenever the temperature is more than 33, bulb turn on.
Actually, I artificially increase the temperature. Normally, it's not possible that I can increase the temperature by this much, from 29 to 33.
Temperature is 32. Now temperature is 33 and our bulb is on.
So this is how we can interface sensor as well as actuator depending upon the value of the sensor. We can operate our actuator in with the RPI. Now we want to send the information of temperature and humidity on cloud. This is ThingSpeak Cloud, which can provide us a free space to display our value. But we need to do some formality to take this privilege. So let's have what are the formalities. This is a cloud service requires setting up a new user account and retrieve API key and channel ID. This is what we need to get before using this ThingSpeak Cloud. So let us see how we can get all these facilities. So first of all, we need to type a ThingSpeak on your browser. Then when you click on this, then the sign in facility will give you this screen where you need to put your valid email address in order to create your account. When you create your account, then some formalities you have to be complete, and after this is the finish your account creating procedure, and you need to set a password. Okay, and then when you sign up successfully, this screen will appear on your screen. And sometimes, in fact, this is always asked that for what purpose you are going to use this facility, ThingSpeak Cloud facility. So choose appropriate information. Since we are teaching, so I choose this one. And then now they allow me to create my own channel on their cloud. So this is my channel. I choose this new channel because I want to create a new channel. And when I click on this new channel, this screen appears on my screen. And then this is what I put over here. New channel. So I put a name over here. That is my IoT project, is the name of my new channel, some description. And I only create 2 fields over here. Only 2 fields for temperature and humidity. You can choose as many as fields you want to do. Because I am having 2 information, so I choose temperature and humidity information in 2 fields. If I am having some other information, then I can write over here and so on. So this is what I have done now. And as soon as I completed that formalities, this screen appears on my channel, and this is for field 1 information, and this is for field 2 information, temperature and humidity. So now I can interface my information of sensor with cloud ThingSpeak and continuously send the value of temperature and humidity on cloud. This is once again the same view. And in fact, you can import or export your data to display on your cloud. If you import the data, you can put on the graph just to display. And if you want to export the data, this facility is also there, .csv file in the form of .csv files. These are the 2 main things
important things when you create your account on ThingSpeak. When you create your account, they provide you a channel ID. You need to keep this safely, and two keys, that is write key and read key. Write API key and read API key. Write API key is just to write some information on cloud, and read API key just to read some information from cloud. So if I allow you to read my information, then I should share this information with you. So I just noted it down. In order to program, these are some codes in order to interface cloud with RPI from library, and this is my API key, which I must inform in the through the program, and this is our DHT sensor. This program is available with you because we are sharing this study material with you, so don't worry. And now this is what I can display on my channel: temperature and the humidity. You can see the temperature is 30 at the time of that is 14.50, and the corresponding humidity is 41. Cloud send after every 15 minutes. Cloud receive the information after 15 minutes, 15 seconds, not 15 minutes. It's a 15 seconds, after every 15 seconds. So this is the normal temperature, but just to show that our true value is sending to the cloud, I artificially created the temperature variation, and this is the temperature after few seconds, that is 37, and corresponding humidity is 27. So this is how you can store, you can send your information from RPI to cloud. Interfacing of sensor with RPI, collect the information from the sensor, and then send the information to the cloud. This is a complete project of IoT based. I hope that is clear now. And the next interfacing we are going to see is RPI interfacing with OLED. OLED stands for Organic Light Emitting Diode. This is a screen. We are using this as a screen. So miniature OLED display module, we can add a small screen with our RPI. Normally the available size is 96 inches. Although this is available with various size, but I am using this size. And 128 by 32 and 128 by 64 pixel are the common available OLED. It has 4 pins, 2 for the power and 2 for I2C interface. It works on this protocol. So 2 pins for data and clock. This is the pin diagram. You can see we connect our VCC pin to pin number 1, ground to pin number 14, and clock to pin number 5, and SDA to pin number 3. By default, as I informed earlier also, by default, this interface is disabled. So you need to enable this interface either by selecting the preference click or by writing a sudo RPI config on your terminal. As you write this command on terminal, this picture, this window come up across you, and just choose this I2C, I2C enable, and then once again boot your RPI. Otherwise, this is not activated. In order to implement this facility, you need to reboot your RPI. And these are the some library we need to install before interfacing this OLED with RPI. Although we have already installed some of the libraries, but I wrote here once again, suppose somebody wants to interface only OLED. So that was the library. And the second most important thing is we must know the address of our OLED. So this is the command with which you can find out the address, and this is 0x3C is appeared on your screen as soon as you write this code on your terminal. this is what appear on your screen, and finally you find out that this is the address, because you need this information in your program. So these are the some once again software requirement. Sudo apt install this Git. You need to install first of all Git, and then clone this library, that is Adafruit Python SSD 1306.git, in order to support this OLED interface. Then move inside this folder and install the Python. And finally, this is the Python code you need to write on your .py file in order to execute, in order to display your information on an OLED screen. So this is some library. This is just to import some image and support the image. These are the instructions to display your screen, clear your screen, and to inform the display what is the address of your board, that is 0x3C, address is equal to 0x3C, and so on. And this is create blank image for drawing. So these are the formalities. When you first time interface your OLED, you must perform. In fact, some other information also you can insert over here, like font and font size and different type of font. As I have not used, that is font 18, font 20, font 24. These are the facilities available, but I use by default font. So this is what the information characteristic we can use when we write program, just in order to give a shape, size, and other features to our display. And finally, I am using 2 lines. So this is the code to display my image in 2 lines. And once again, the code to activate our sensor. I'm using the same pen as I once interfaced my DHT sensor with RPI, and keep this intact throughout the demonstration. So this is the same pen, again the same information. Once again, this is to give the proper space to our display text in X horizon, at which place. This is the font size. I wrote here font is equal to font because I have not activated some other font facility. I use only default font. Now you can see the interfacing as well. Going to interface OLED display with RPI, and this is our OLED board with 4 pin, ground, VCC, SCL clock, and SDA. And this is the GPIO pin structure of our RPI. You can see over here, physical pin 3 and 5 are SDA and SCL deputed pins. VCC we can connect on physical pin number 17, as this is with 3 volt, 3.3 volt, and for ground we can take pin number 39. Let's start connection. Pin number 39 for ground. So here we go. It's a 39, and VCC, as we have seen physically, it's a 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and this is the 17 number pin. Now we left with the clock and the data pen, and clock is 5 number. Clock is 5 number, so this is 1, 2, 3, 4, and here this is 5 number, okay. And finally SDA pin on pin number 3. So now we are going to insert this SDA pin on pin number 3. All done. You can see over here our DHT sensor is already interfaced with RPI, because we are going to display temperature and humidity on this screen. Let's start our Python code. Let's see. I have already inserted the Python code, and this is mentioned in my PPT. Now I'm going to run this code. Take some time. Okay, now you can see over here, this is what we want to. Temperature and humidity displayed on our OLED screen. This is also shown on the screen of our display. I hope this is clear how we interface our OLED with RPI. And finally, we interface our camera module with RPI. This is camera module. Just to, if you remember, that is a particular camera slot is there in our RPI. But ensure your RPI is turned off when you insert the camera ribbon in your RPI. Gently pull up the edge of the port, plastic clip, and insert the camera module ribbon cable. Make sure the cable is right way round. I'll show you a video before starting this. So now we are going to interface camera with our RPI. So gently pull up this slider and then insert the camera module in such a way that this ribbon inserted in the slot. Make sure that your RPI is shut down during this activity, and then gently push down this bar. This is how we can hardware interface with the camera, our RPI hardware interface with the camera. And the code we need to run for operating this camera is go to the once again, just keep in your mind that we need to enable our camera module from configure RPI configure command, either RPI configure command or by preference menu. In the preference menu also you can see the camera module enable disable facility. So in any with the facility of any of these facility, you just enable your camera module, and then only the camera is activated with your RPI. And after successfully interfaced camera with RPI, these are the command in order to take the still image or the video from your terminal. For the still image, you need to write this RPI still dash O desktop. This is the place where you are going to store your image. If you want to store your image desktop, then just put over here desktop. If you want to keep the name of your image is image.jpg, then write over here image.jpg. If you want to keep the name of your image is something else, then write over here. And if you want to keep your image or store your image somewhere else, then also you can change this. So this is for the still image, and this is for the video. For video RPI with once again the dash O. If you want to keep your this video on the desktop itself with the name of this, then write this information. Otherwise, you can change this information. So this is the facility to click your image or to make your video from terminal window. But if you want to write a program .py file, then also this is possible. Then that you can create a .py file. For this, you need to import some libraries. Then from PIEMR, import PIEMR, and then from time, once again, import the time, or the simple that normally we can do is import time also. Camera, now PIEMR, and here what we are doing is we just take a preview. We are taking a preview. So before taking the picture, it gives you a chance to see the preview, and if you want to change, you can change the orientation or the location of your object or whatever you want to do. And after 5 seconds, you can set more than this. After 5 seconds, the preview will stop. And in order to capture, this is only for the preview. These codes are only for the preview. And if you want to capture the picture, then just insert a new code, extra code, that is camera.capture. In between this, start the preview, slip over time, that is delay in fact, and then insert a code. This is camera capture. So it will take a still image after 5 seconds of preview. When you start your programming, then it will give you a preview, and then after 5 seconds, automatically it will capture an image. And if you want to take more than one image, then this is also possible. You by the software programming, you can put any information in the Python code and take the picture and save the picture where you want to be. And this is the code for I in range 5. So it will take 5 pictures after every 5 seconds. This is once again preview is also there. So capture is also there. So it will take the still image after every 5 seconds. Then recording is also possible with the .py file. Camera start, once again the preview is there, and camera.start command is for recording also. Recording, and this is the place where you want to keep your recording. Then this is the delay between the recording. Delay means recording start and recording pause time. आपने जब रिकॉर्डिंग स्टार्ट करी है और जब आपने स्टॉप करी है, सो दिस इज द रिकॉर्डिंग ड्यूरेशन. So this is the camera interface with RPI, and in all, we have seen in this session what is RPI hardware, how we can install OS in RPI, how we can interface sensor with RPI, and we can take the value from sensor and activate our actuator. And finally, whatever we read from the sensor, we can send to the cloud. Also, we can display that information on our display, and we chose here OLED. And also, we can interface our camera with RPI. So you all are, I hope, understand whatever we have discussed. And if you have any query, then you can ask me.
Any doubt or any query regarding this? So you can ask directly or you can write on a chat box. Video images or video pictures to this Raspberry Pi?
Yes, yes, sir. Of course. You changed your code as I wrote there h dot something, and you can change that MPG and other format. And as
So it
well
will
as
support
we
all
are
the
having
formats?
some other facility. Yes, yes, yes. And in fact, there are settings where you can set the pixel values as well as size, but it needs some coding. This is the simplest coding I explain here, but you provide some extra information to RPI to resize your image, to change the pixel value of your image, etc.
Okay.
This is possible.
Any participants, other participants? No, madam. So you can continue.
Okay, so this is all from my side, and
So,
the PPTs are available with Vaibhav sir. In fact, recording is available with Vaibhav sir.
can we use can we use a RPI for face recognition?
Of course, sir, RPI can be used for face recognition, but not directly. I mean, if you are talking about the camera point of view, then it can tag the picture. But as well, if you are talking about the machine learning point of view, then also this is possible that you can train your code, train your model, machine learning model, and deploy this model, in RPI. This is, but the condition is which RPI you are going to use, because the initial RPI was not with that much of memory. But right now we are having RPI 4, which is with the 8 GB memory. Then this is possible if your model is not trained with much data. Then the size of the model is small enough. Then you can deploy that model in RPI itself, and you need not to do processing on cloud. So it's a very fast activity, in fact. The normal thing is, normally what we are doing, we just send our information to cloud for processing purpose, and then receive the result and so on. But if the model is very small, then we can deploy that model itself on the RPI.
Means you can use that face recognition system.
Yes.
But the latest version for RPI is RPI 4 now.
RPI 4 with 8 GB. RPI 4 is available with 2 GB, with 4 GB, with 8 GB. This is the latest version of 8 GB. Well, I have shown it in my video, but I have performed all the experiment with RPI 3, because at that time we are having only RPI 3. RPI 4 we received, in fact, day before yesterday. So we purchased new one. So we received this board day before yesterday. So we have performed all the that is experiments on RPI 3.
Okay.
You can take a picture with the RPI. I have interfaced simple with the simple camera, but we are having the high resolution camera also.
Yes.
HQ camera, which is compatible with RPI, and That camera, in fact, I have seen somewhere that camera is used to take the picture of moon. Of course, with some additional accessories. But I mean, I just want to give you the information that that camera is that much of capable that people are taking picture of moon. So this camera is compatible with RPI, and this is launched in 2020 itself in April 2020. High quality camera, 12 megapixel. And we are having right now we are having only 2 or 4 megapixel cameras with us, but that camera already launched.
So any other question or any other query regarding this session? Otherwise, thank you very much. Thank you so much.
Thank you, sir. Thank you all participants for listening me with patience.
One request from my side, from the Rajkamal session or from your session, please
of course,
we'll provide
you.
And send it to the email.
Okay. Thank you. Thanks, sir. Okay.
Yeah. For today's session. Yeah. Okay. Thank you. So thank you, participants. I have already sent you the link, Google Meet link for the third day, and the speakers for tomorrow's sessions are for Pramit Gupta from IIT Indore and Dr. Shukla from IIT Indore. So the next we'll meet tomorrow sharp at 10 a.m. Okay. Thank you so much.